Financial Modeling, Topic 7, Section 4. We're going to create an at-risk portfolio model with multiple periods, changing asset allocations, and contributions. Going to our spreadsheet from the last section, we've created a deterministic or static portfolio model that gave us $1.3 million and an annuity of $71,000 for 30 years. We then did a macro simulation, making those returns stochastic by saying the portfolio grows by 1 plus the mean in each year, plus a random value, random z times the standard deviation, plus my contribution. Now this model, we're going to use at risk. I have at risk launched, and you'll see that my portfolio model is the prior balance times 1 plus the mean plus risk normal 0,1 times the vol plus my contribution. I'm going to copy that down. What that does, that's going to create 40 plus random numbers to simulate the 40 plus variations of the market every year. I then notice that while that formula is sitting in that cell, risk normal 0,1, how at-risk handles the spreadsheet is it's going to keep a static value of 0 in the cell while not running a simulation. So as far as Excel is concerned, the actual worksheet, all I have is 0 times the standard deviation, which gives me the exact same value as the static value. However, I'm going to run a simulation, and these risk normal 0,1s are going to get randomly generated. 0 mean, 1 standard deviation. I'm going to make these 5 cells my output, so I'll click on all 5 of those. I'm going to hit Add Output, hit OK. So if I go to my model window, what you'll see is I have a lot of risk normal 0,1s. Looks like I have, well, let's see at the bottom here. Looks like I've gone down to 79 of those. And if I go in output, I've got 5 outputs. This is what's going to generate that distribution or the histogram. Let me move over a little bit. And I'm about ready to go. So what I want to do is I'll click on this cell so I can see it in real time, what's happening to my portfolio value. And I'm going to run 10,000 iterations and start. So now what at-risk is doing is it is generating 10,000 sets of 79 risk normal 0,1s, which are independent from each other. And what that's going to do is graph our distribution of portfolio values. So I'll let that run for a minute. This is giving me a status. Now what I'm going to do when this is all done, I want to compare the graph that gets generated by at-risk with the average or mean, 5% small and 5% large of my simulation using a macro. Since both of these models use the random walk model of mean plus random z times vol, it should give me roughly the same values as this. So looks like it's almost done. There's my graph. And where'd that go? Let's get that again. I'm going to click on this cell, hit Browse Results, and pull up my graph. Well, looks like my graph went off my screen, but let me show you what it shows. If I look at the portfolio values and I click on a 90% confidence interval, in other words 5% in each tail, it tells me the portfolio value, this cell here, has a mean of $1.3 million The 5% lowest looks like they converted this into millions is $580,000. Notice that's about the same as my macro generated results, right? The 5% lowest of these 5,000 outcomes. The 5% highest, 2.51 million, that's about the same as my macro generated, kind of homemade Excel Monte Carlo simulation. If I look at the retirement annuity, this cell here, the output of that one, 5% lowest and highest, 31,000, 136,000. That's the 32,000 and 137 right here. And the real annuity, 26 average, and between 12 and 51. 12 and 51. So what you're seeing is at-risk is giving me the same exact values or similar values as doing the 5,000 simulation or iterations before. So the question now is the 10% savings rule matched together with the 120 minus the age and stocks rule appropriate? Well, that's to be seen in future lectures, but just looking at this data, that model is expected to give me or to replace about 49% of my income, as low as 22% of my income, and as high as 93% of my income. So the problem is, what if it is this low? Maybe I should be saving a little more. What would I do if I wound up in this outcome? You know, the random gyrations of the market where there are a lot of negative Z's. You know, there's a lot of crashes in the market, and I wind up in this situation. So it's not clear. I think we're going to need another model, and we're going to do that in the next topic. Or I'm sorry, in the next topic 8. However, in the next section, we're going to start talking about in retirement, how do I think about withdrawing money? How much can I safely withdraw?